So we are from the Volcani Institute, which is the research arm of the Ministry of Agriculture and Food Security, the Israeli ministry. And we both co-coordinate the CrackSense project. Victor is in charge for the technical part, and I'm in charge for the horticultural part. I'm a citrus physiologist, and I work on different aspects of citrus productivity and fruit quality and so on. And CrackSense is very important in citriculture as it is in other crops because it may cause damage to the yield. Depends, of course, on the cultivar. And we had some cultivars which were quite severely affected by cracking intensity, and they were simply eradicated.
I am an agricultural engineer from Volcani Center in Israel. My expertise is sensing and data technologies. Cracking is a severe agricultural problem, but the technologies that we have today can be used in order to solve it using data-driven methods. So we are trying to use sensors and data to put everything together in modern algorithms that can explain the risk of cracking, the phenomenon of cracking, so that the farmers will have the opportunity to use whatever management procedures that they have in order to mitigate the cracking.
So the first 2 years of the project, which terminated this year, were devoted to place or to generate experimental plots in which cracking intensity shows variation in the same plot. And we did experiments in 4 crops, in pomegranate, in citrus, in sweet cherry, and in table grapes in a few locations in Europe as well as in Israel. And the idea is that these experimental sites would serve as an infrastructure for the sensing, to test the sensing technologies. And so far, I think that in most cases we're quite successful. Experiments were successful in that sense. The plot generated varied cracking intensity, and in these experimental sites, sensing tools were applied. And now we can say that we started to model the relationship between cracking intensity and data driven by sensing technologies. So the limitation of sensing tools is that they cannot detect cracking directly, the fruit cracking directly. So we have to monitor fruit physiology, tree physiology, tree health, and correlate it to cracking intensity. And in that sense, we are in the right direction, the right path. We already have a proof of concept for that we can use sensing tools, especially remote sensing tools on UAVs, to detect or to predict cracking intensity.
Yeah, so CrackSense is a data science project. The physiological and the agronomical part, which was the main part in the first 2 years, provided extensive data. And now we are in the stage where we have to build the models. We intend to build models of AI, artificial intelligence, and machine learning in order to find the connections between the prediction of risk of cracking and the data that we collect. And we will try to do it in several scales: the scale of the tree, the scale of the plot, the scale of the region. And the data for those models have been already acquired and collected during the first 2 years. The rest of the project will be devoted to implement those models and try them in pilot plots, in plots where we do not have any more experiments, but we will try to apply them and see what is the accuracy of the models for predicting the risk of cracking.
So the integrated solution of CrackSense should result in a prediction model which can serve the growers, can serve policymakers, again, to assess, as Victor mentioned, to assess risk of cracking. And sometimes the assessment, the assessment is very important. If the prediction is for high cracking intensity, then the farmer or the grower can decide that to take measures or to avoid different measures in order to reduce the economical damage.